All right, 1.6c, quadratic-like equations. This should really be nothing new for everyone. The reason why I'm saying that is because if we go back to, let's go trip down memory lane, we're going to go back to R4 and, oh, look, factoring by substitution. We went through and we said, okay, fine, we're going to treat this like, sorry, got to get my pen ready, 15x squared minus x minus 6. And then you'd go through and you'd factor that, and then you would plug the x squared back, you know. This is essentially, we're doing this substitution step of x equals h squared. It's supposed to be an h. Sorry. There. So let x equals h squared. This becomes x squared. This becomes x. Hey, we know how to do this. And then at the end, once you get the answer, what x is, you're going to plug the h squared back in, and away you go. Same thing here. Okay? So again, same big idea. You're making a substitution to turn a problem into something easier with which to work. One of our overarching themes of the year is to bending math to your will, making it do what you want to do, or looking at a simpler problem, figuring that out, and then applying what you know. Okay? So both of those apply here. So I'm going to walk you through a couple examples and then turn you loose because, again, you did this back in R4. It shouldn't be that big of a surprise. Here, 6x to the fourth minus 13x squared minus 5. If you want to get all, I'm going to change colors here just so it stands out better. If you want to get it so it's easier to see, all you need to do is you're going to say something like let, I don't know, let's say a equal x squared. And why x squared? Because again, this is the relationship between the terms here. This variable, x squared gives me this, x to the fourth. So that gives you an idea there. So what we're going to actually treat this as is 6a squared minus 13a minus 5 equals 0. You can factor this. You could quadratic equation it, complete the square. However you want to do it, you can do that. Okay. So, just off the top of my head, remember if we're going to do factor by grouping, 6 times 5 is 30. We're looking for a 13 down here. A couple different ways you could do that. So initially you think 10 and 3. Since we're talking about a negative here, you're looking probably more like probably 2 and 15. So we should be okay there. So again, 30 breaks down into, well, you know what, you guys know how to do that, so I'm not going to spell all of it out. What it does break down here into is I'm going to have 6a squared. And then the 30 you can break down into 15 and 2. So I'm going to say minus 15a plus 2a minus 5 equals 0. And then from here, we're going to break this down into 2 separate groups. Let's see if we have something that's in common. You can pull a 3a out here, remember. You have 2a minus 5. Hey, that looks familiar. Now, there's nothing really to pull out here, so technically we're factoring out a 1. Okay? Pull out the 2a minus 5 out front, and now we know what a is going to be equal to. Now, again, remember, we're not solving for a, we're actually solving for x. That's going to be where the fun is. Give myself a little bit more room here. So from here, again, zero factor theorem, a is either going to equal 5 halves, or on the side a, oops, I think my handwriting is getting better, negative 1/3. Now remember, back up here, we've got this little step. So now we're going to resubstitute that back in, and this is where I said probably too much already, where the fun begins. So So now I'm going to get x squared. Oops. Try to get fancy and look what happens. Equals 5/2. And x squared is equal to a -1 over 3. Now since we have x squared here, you know you're going to get imaginary numbers at least here on the right hand side. So x, oops, is going to equal plus or minus the square root of 5. Now you could write this as the square root of 5/2. I find that if you break it down like this, then you're not going to forget about rationalizing the denominator here. So I'm going to multiply through by square root of 2 over square root of 2 as a quick little review. So one of your sets of answers is going to be x is going to equal plus or minus square root of 10 over 2. A couple last comments. No, you can't divide the 2 into the 10. Yes, remember when you multiply radical 5 times radical 2, you multiply the insides. Okay, so that's 2 of your answers. And again, and we'll get more into this in a couple months. Generally, this right here, the exponent with the highest degree of an equation is the most number of unique answers you can have. And so in this case, we've got 2 here, and we're going to get 2 out of this one. So x is going to equal plus or minus negative square root of 1, or square root of -1 over square root of 3. So we are going to have to deal with imaginary numbers, but being the professionals that you are, that will not be a problem. Okay, so we're going to rationalize here. And so then x, on this case, is going to be, this will be turned into an I. I forgot the plus and minus up here. We're going to have the square root of 3, and then we're going to go over 3. Now be careful on these, particularly like when you're talking about SAT, ACT questions. See if they're looking for all the answers or just the real answers, because the second set of answers here isn't real. And not that that's necessarily a problem, but make sure that you're answering the question that's being posed to you. So we're going to be all fancy here. Some mathematicians everywhere can love us for our thoroughness. And there is your set of 4 answers. Ta-da! Not so bad. So again, it's basically, I mean, it's like so much we're doing this here, we're taking 2 ideas that we both know how to do. Factoring quadratic-like equations, we know how to solve quadratics, merging them together, trying to build a better America. All right, one more. Oh no, you've got fractional exponents. Again, no big deal. This is quadratic-like because x minus 3 to the 1/3, if I square that, I get x minus 3 to the 2/3. And so our little substitution step here, and again, this is something where it's helpful to write this down so you don't make too many mistakes. Now this is going to be this whole expression, and I'm even going to take it up to the 1/3 power, because what that will allow us to do is, if I rewrite this, this becomes 2a. That equals 3. And this over here, remember, this is essentially x minus 3 to the 1/3 squared. So that's going to be turned into a squared. You gotta move everything on one side, so you set a equal to 0, a squared plus 2a minus 3 is going to equal 0. So factoring wise, this actually isn't too bad. You get a plus 3, a minus 1 equals 0. So then a equals -3, a equals 1, and then we're going to substitute this back in. And then we're just going to solve it like you guys were doing. This is essentially like the radical equations we were doing before. So I've got x minus 3 to the 1/3 power is equal to a -3. And then over here I'll have x minus 3 raised to the 1/3 power is equal to 1. How do I undo take this up into 1/3 power? You cube everything. So this is now going to become x. I'm going to write it like this, just to make it, just to be safe. So this, anything to the 1/3 power, raised to the 3rd power is just going to be whatever you're taking the power of. And then you get x minus 3 is equal to a negative 27. So one of your answers is going to be x equals negative 24. And then over here, you can do the same thing. I'm going to raise this to the 3rd power, and this to the 3rd power. So now I have x minus 3 is equal to 1, so x is going to equal 4. Now again, particularly when you're dealing with roots or fractional exponents, you always want to double check your work pretty quick. So if I plug a 4 in here, I've got 1 to the 1/2 power, so that's just going to be 1, plus 2, because that's again a 1 here, is going to equal to 3. Okay, 4 checks out. A negative 27, if I plug, or negative 24, if I plug in negative 24 and negative 27, cube of that is going to be 9, minus 6, because again, the cube root of negative 27 is negative 3. You're going to work out there. So both of those answers check out. So you're going to write down in numerical order from least to greatest our solution set. That's your answer for that. All right, so that's 2 examples. Again, find the part that's being squared from one part to the other in the equation. That's going to be a substitution step if you need to write it out. Do it, solve for that variable, reverse the substitution, and solve the 2 remaining equations. Thanks. We'll talk to you later. Enjoy. Oh, before I forget, the classwork that you're going to be working on here then is going to be the only assignment from 1.6c. I think I forgot to put that on this slide. Oh, nope. Review time. So, my deepest apologies for those of you following along. So, your big question here is how can you turn this into something I can do, or something similar? And remember also, there's your work. So, you work on the section, it's page 144, and you've got 5 problems like this, because obviously a little bit more involved. So, we'll be doing that in class, and if you have any questions, give me a yell, phone, email, text, whatever you need to do. Talk to you later.